this end, and that will cut, and both these will meet at one point. One point is here, another point is here, right? That we have picked up point number 2. Now for point number 3, with the same steps, from point number 3, draw straight vertical line, transfer that point to here. It will cut the circle at this point. Here one point is here, another point is here. So from this point, draw straight vertical line, and from this also draw vertical line, and both will meet horizontal line from point 3 at these 2 points. Similarly, point number 4 would come here, point number 5 would come here, here and here, point number 6 would become at point number 4, point number 7 at point number 3, point number 8 at point number 2, and 1 back to 1. Now join all these points with a smooth curve, so it would appear like this. One is here, another is here. So this would be the curve of intersection for this square prism, and here, as it's a square prism, this edge would appear, this edge, and after that it is inside the cylinder, so that edge would be not appear, to be represented by the dotted line. Similarly, in top view also, here the edge would appear up to this end, and inside this circle or cylinder, it would appear as a dotted line. So this is the solution of this problem, and you can insert the dimensions. This is diameter 100, length 160. This is the square of 50 mm sides, and length is 140 mm. I hope the solution is clear to you. Now let me quickly revise these steps. This is the cylinder having diameter 100 mm. How we have drawn this? Insert the dimension, draw its axis, both the axes, name the endpoints 1, 2, 3, 4, transfer the points from top view to front view, draw a rectangle having height 180 mm, which is given in the data, and draw a rectangle, right? Now draw meter line, transfer the points to meter line from its top view by drawing horizontal lines from respective point, and from that meter line draw its side view by taking projections from top view and front view. So this rectangle shows the side view of the given cylinder. Then draw axis of this cylinder like this by the center line, and then find out the midpoint by drawing horizontal axis. Draw a square in such a way that all the lines makes angle of 45 degree with XY line. Name the endpoints A, B, C, D. Transfer all these points to its front view. So this would be its front view. Transfer to meter line to top view, and this would be its top view. So we have drawn 3 views of both this combination of these solids. And now find out points of intersection by drawing straight lines from this cutting point, the points of intersection. Name the endpoints, straight line from this end, and join all these points with a smooth curve like this to this. Erase this line, as it would be dotted line because it's a hidden line. So this also would be dotted line. This line is full line, so make it dotted. This is full line. Insert the dimension square 50. This line also would not visible, this one, so that is to be removed, and draw dotted line like this. It would not be full line, it would be dotted line. And then insert the dimension 1, 2, 3. Name the views. It's a front view, this is top view, and this is side view of the problem. So these are the steps to be followed to draw this problem. Now problem number 4. The data is given like this. A cylinder of 60 mm diameter and 70 mm length stands on its base. A horizontal square hole of 35 mm sides is cut through the cylinder. Here a cylinder is standing on its circular face and a square hole is cut through the cylinder. The axis of the hole is parallel to VP and bisect the axis of the cylinder. Draw the projections of the cylinder showing curves of intersection with the side face of the hole inclined at 30 degree to horizontal plane. So here first we have to draw the cylinder of diameter 60 millimeter and height 70 millimeter like this. So first we draw a cylinder. This is the cylinder, top view of the cylinder, and draw a meter line and XY line to transfer the points from this top view to the side view, and draw the side view of this cylinder as well by drawing the meter line and taking projection from its top view. So this rectangle represents the side view of this cylinder, and here this rectangle would represent the front view of the cylinder. We will not draw full length in front view because some points would be dotted line. So this is the front view and side view of the cylinder. Now we have to, it would be needed to locate the axis of the cylinder. So it would be drawn like this, axis from this point, from here draw straight vertical line. So this is the axis of the cylinder. Now we have to draw the square in such a way that its center would be this one, and the sides makes an angle of 30 degree with horizontal plane. So the square should be drawn like this. This is the square such that its two faces makes an angle of 30 degree with XY line. This is given data. You can use any trick to draw this square. For example, from this point you can draw a line at an angle of 30 degree, and then according to the side, that is 35 mm, 17.5 on this side, 17.5 on this side, you can mark the points and locate the end points of this square hole. So this is the square hole which is cut in the cylinder. Now this square hole would appear as a dotted line in its top view. So transfer the end points of this square hole like this, vertical lines from all these points like this, vertical line from this 1, 2, 3 and 4, from all these 4 points. So this is point number 1, 2, 3 and 4. Transfer all these points to here. So 1 would be here, this one. So and it's a hole, so edges would be there, and it's inside the cylinder, so fully dotted line would be there. This is point number 1, this one. Now point number 2 is here, so for point number 2, this would be the dotted line which represents the corner 2. Point number 3 is here, so that could be represented by this dotted line, that is point number 3, and point number 4 is here. So from here draw straight vertical line and then draw dotted line. So this is point number 4. All 4 points are located in top view. So if we cut the cylinder in top view, it would appear like this. Now how would it appear in front view? So for that again we take projections from each point, from one horizontal line, from one vertical line. One point would be here, from 2 horizontal line, from 2 vertical line, from 2 horizontal line, from this 2 vertical line, that point would be here. So this is point number 1, this is point number 2, point number 3 is here. So horizontal line from point 3, vertical line from point 3, horizontal from point 3, and transferred from the cylinder to here. Then point number 3 would be somewhere here. So 1, 2 and 3 points would be here. Join all these points with a smooth curve. So it would appear like this. And on this side it would be asymmetrical shape. It's a smooth shape, but it's not symmetrical, it's an asymmetrical shape. Similarly on this side also we can transfer the points. Say here is the point number 2, it will cut the circle, one point at here, another point at here. So from here also draw straight vertical line, horizontal line from point 2, both will cut at this point, that is point number 2. Point number 3, horizontal line from point 3, from 3 here, so here point would be there, and point number 1 would be here. So on this side also draw with the smooth curve, join with the smooth curve. This would be asymmetrical shape of this intersectional hole. Now what's about this back side, that is point number 4, 1 and 3 on the reverse side. So to find out the position of those points, let me pick up point number 4 here. From 4, straight vertical line, horizontal line, it will cut the circle at this point. So from this point draw straight vertical line, from this point also draw straight vertical line. Now from point number 4 draw straight horizontal line, and both will cut at 2 points. One point is here, another point is here. So that is to the back side of this cylinder, so it will not be visible. So join all these points with a smooth curve and with the dotted line, because it will not be visible. Let me use another colored pen to differentiate between these two sections. This dotted line represents the back side of this hole from here to here, and here also it would appear like this dotted line, and here also one dotted line, right, the back side. Similarly, these two points would be joined with the dotted line, because it's a corner number 4 which is behind side, so it will not visible. So corner number 4 would be drawn with the dotted line. This corner number 2, what do you say about this corner number 2? It would be visible, but inside it would not be visible. So here also dotted line would be there from this end to this end. Now what's about corner number 1? That also would be here, so that to be represented by dotted line over here, that is corner number 1, and corner number 3, this one, that also to be represented by the dotted line from one end to another end, which is not visible here. So this is the hole. Now if it shows that if we cut a square hole in a vertical cylinder, this would appear like this. Now let me insert the dimensions in this figure. This is the square of side length. You insert the dimension like this. It's a square of 45 millimeter size, right? SQ 35. Sorry, 35 millimeter is the side length, so SQ 35. Height, that is not given, so not needed to be inserted in the diagram. Whichever dimensions are not given, or we have to assume that may not be given in the figure. This is the cylinder having diameter, so diameter to be represented by phi. It's a diameter 60 millimeter, and here 1/1 scale is used, so no need to write the scale. Then after, the last step is to represent the axis of this solid. It's compulsory to represent the axis of the solid, so let me represent the axis of this cylinder by drawing center line at the middle, which passes through the center of the circle in top view, this one. Similarly, the center, this is the axis of the cylinder, and in this front view, in the side view, this would be the axis of this cylinder. Similarly, axis of hole can also be drawn like this. This is the axis of the hole, so from this point draw a line like this. This is shows the axis of the square hole which is drilled in this vertical cylinder. So that is problem number 4 that we have discussed. Now problem number 5. The data is given like this. A vertical square prism with 50 mm base, 110 mm height, standing on its base with a vertical face inclined at 30 degree to vertical plane. It is fully penetrated by another square prism of 40 mm base, 110 mm axis. The penetrating prism has its axis perpendicular to profile plane and 10 mm in front of the axis of prism. The rectangular base of penetrating prism is inclined at 30 degree to HP and its axis is 55 mm above the base of the vertical prism. Draw the lines of intersection. So here two square prisms are given to us. A vertical square prism in which the sides makes an angle of 30 degree with VP. So first we have to draw a square prism such that its sides makes an angle of 30 degree with horizontal plane like this. This is the square prism which is as per the given data. Two sides of this square prism makes an angle of 30 degree with HP and its side view would appear like this. This is the side view of the cylinder from this end to this end. And now it is given that now we have drawn this vertical square prism as per given data. Now it is given that it is penetrated by another square prism such that the axes are 10 mm away from each other. So first we have to locate the axis of this vertical cylinder, vertical square prism. So this is the axis of this vertical square prism, this one. Transfer this axis to its front view. Right. Now it is given that at a distance of 10 mm from this axis, the axis of another square prism is here. So we have to draw here another axis of the square prism like this. This is the axis of the square prism, and from here draw straight vertical line. And from this point here is the axis, and here at the middle, if we draw a straight horizontal line, this is the point or axis of the square prism which makes an angle of 45 degree with VP. So we have to draw a square in such a way that it makes an angle of 30 degree with XY line